Voyager, humanity's farthest messenger. The most distant human-made object in the universe is none other than NASA's Voyager 1 spacecraft. It's not just adrift in the dark, it's the first human creation to cross into interstellar space, a domain that lies beyond the influence of our sun. That's more than just a milestone in spaceflight, it's a monument to human ambition, engineering brilliance, and scientific curiosity. Now imagine this. A spacecraft built in the 1970s, before the age of smartphones, before the internet was widespread, before personal computers became household items. Launched over 45 years ago, Voyager 1 is still communicating with us today from over 14 billion miles away. That's so far, it takes more than 22 hours for its signals traveling at the speed of light to reach Earth. Even more astonishing is the fact that Voyager 1 is still sending back valuable scientific data using technology older than a cassette tape player. Its memory? A mere 69 kilobytes, smaller than the size of a modern thumbnail image. Its transmitter? Just 23 watts of power, about the same as a refrigerator light bulb. And yet, this aging spacecraft continues to operate, outliving expectations by decades. Voyager 1's original mission was relatively modest: to fly by Jupiter and Saturn, capturing images, analyzing their atmospheres, magnetic fields, and observing their many moons. This mission was intended to last only 4 years. But Voyager didn't stop there, it kept going, and so did our fascination with it. The story of Voyager's origin is itself a tale of visionary science and celestial timing. In the 1960s, NASA engineer Gary Flandreau at the Jet Propulsion Laboratory discovered something remarkable while studying planetary orbits. Using only a pencil, paper, and his expertise, Flandreau calculated that in the late 1970s and early 1980s, the four gas giants Jupiter, Saturn, Uranus, and Neptune would align in a rare and favorable formation. This unique planetary alignment, occurring just once every 176 years, presented a once-in-a-lifetime opportunity. It would allow a spacecraft to use each planet's gravitational pull as a kind of slingshot to accelerate and continue to the next world in line. This method, called a gravity assist, could reduce a journey to Neptune from 30 years to just 12. This window of opportunity would not return for nearly 2 centuries. Faced with this rare cosmic configuration, NASA acted swiftly. They developed 2 nearly identical spacecraft, Voyager 1 and Voyager 2, and launched them just 15 days apart in the summer of 1977. Their mission? To explore the giant outer planets, take advantage of the gravitational boosts, and push the boundaries of exploration farther than any spacecraft had gone before. Though the spacecraft were similar in design, their routes differed slightly. Voyager 1 would prioritize encounters with Jupiter and Saturn, while Voyager 2 would continue on to Uranus and Neptune, completing the full grand tour. Both spacecraft would go on to rewrite our understanding of the solar system. Voyager 1's early observations were nothing short of revolutionary. It revealed the churning, colorful atmosphere of Jupiter, home to the giant storm known as the Great Red Spot. It captured never-before-seen images of Saturn's rings, uncovering their complex structure and dynamics. Even more startling, it discovered active volcanoes erupting on Jupiter's moon Io, making it the most geologically active body in the solar system, something no scientist had predicted. These weren't just pictures and data points. They were revelations that fundamentally changed how we view the outer planets and their moons. Before Voyager, these distant worlds were little more than fuzzy dots in a telescope. After Voyager, they were dynamic, active, and complex planetary systems in their own right. By the time Voyager 1 completed its flybys of Jupiter and Saturn, it was traveling too fast to be captured by any planet's gravity. It was on a one-way trip out of the solar system, into the unknown. And that's exactly where things started to get even more interesting. Stay with us, because in Part 2, we'll follow Voyager into interstellar space, Voyager's greatest discovery after accomplishing its groundbreaking mission among the outer planets. Voyager 1 did not simply fade into silence. Instead, it ventured even farther into a region of space no spacecraft had ever reached. It entered the vast, mysterious void known as interstellar space, a region between stars, unexplored, unlit, and almost entirely unknown. This new phase of the mission was never part of the original plan, yet it became one of the most extraordinary chapters in the history of space exploration. To understand this next stage, we need to explore a critical boundary in our solar system, the heliopause. The heliopause marks the outer edge of the heliosphere, a massive bubble created by the Sun's solar wind that surrounds and shields our entire solar system. Inside the heliosphere, the environment is dominated by particles and magnetic fields from our Sun. Outside it? The domain of interstellar space, where influence comes not from our Sun, but from the galaxy itself. For decades, scientists had speculated about what crossing this boundary would be like. Many expected a dramatic shift, a sudden drop in solar particles, a burst of cosmic rays, and a clear change in the direction of magnetic fields. But space, as always, had other plans. On August 25, 2012, NASA confirmed what scientists had long suspected. Voyager 1 had crossed the heliopause. But instead of a dramatic border, the transition was subtle, even surreal. The spacecraft registered a sharp and sustained increase in plasma density, which signaled a new environment beyond the influence of the Sun. This was our first direct measurement from the interstellar medium, the space between stars. Yet, to the surprise of many, the direction of the magnetic field did not significantly change. Scientists had expected a distinct shift, assuming interstellar magnetic fields would be clearly different from those shaped by the Sun's influence. This unexpected data sparked debate and curiosity across the scientific world. Was the interstellar magnetic field aligned more closely with our Sun's than we thought? Or was Voyager's path somehow unique, passing through a region of space where the two magnetic fields coincided? Voyager's journey, once again, raised more questions than answers, the hallmark of great exploration. But that wasn't the only challenge. At such extreme distances, communicating with Earth became an incredible feat of precision and patience. Voyager's weak signal, transmitted with the power of a refrigerator light bulb, had to be captured by NASA's Deep Space Network, using massive radio dishes located around the world. Every bit of data takes over 22 hours to travel from the spacecraft to Earth at the speed of light. And yet, against all odds, Voyager 1 continues to send information back, a whisper from the edge of the cosmos. The spacecraft is now headed toward the Oort cloud, a hypothetical region thought to contain trillions of icy bodies orbiting the Sun from a distance up to a light-year away. This journey will take Voyager another 300 years just to reach the inner edge, and it may take 30,000 years to pass completely through it. Beyond that lies the realm of other stars. While Voyager is unlikely to reach another star system within our lifetimes, it is moving in that direction slowly but relentlessly, propelled by momentum alone. Even more poetic is the fact that Voyager 1 carries a message, a gift for any alien civilization that might one day find it. The golden record, attached to the side of the spacecraft, contains sounds and images from Earth, greetings in dozens of languages, music from around the world, and pictures of life on our planet. It is our cosmic time capsule, a symbolic gesture of peace, curiosity, and the hope that someone, somewhere, might hear us. Voyager 1 and its twin, Voyager 2, have far exceeded their mission goals. They have challenged our understanding of the solar system, deepened our knowledge of the cosmos, and inspired generations of scientists and dreamers. What started as a 4-year planetary mission has become a 45-year voyage through deep space, with no signs of stopping yet. Each signal from Voyager 1 is not just data, it's a reminder. A reminder of what humanity can achieve when driven by curiosity, courage, and a desire to understand the unknown. It is a testament to the power of science, the wonder of space, and the resilience of a machine designed decades ago by minds determined to explore. Though its power will eventually run out, and its instruments will fall silent, Voyager's legacy will endure. It will continue to drift through interstellar space, a silent ambassador of Earth, carrying our story across the stars. Forever. If you found Voyager's interstellar journey inspiring, be sure to like the video, subscribe for more stories about our universe, and leave a comment below. What do you think the next big discovery will be out there